Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to do exception handling in C Sharp. The slides in this presentation are based on material from Professional C Sharp 5.0 and .NET 4.51 by Christian Nagel, Jay Glynn, Morgan Skinner, published by Wiley. So, what we're going to look at are the exception handling classes, how to create multiple catch blocks, and several other topics related to using exception handling, and specifically the try-catch block structure. So first, let's look at the exception classes. Exceptions are basically objects that are defined in the exception class, and we actually have a base class called exception, and from that base class exception, we inherit multiple different child exceptions. For example, the system exception class, the application exception class, and the composition exception class. From those, you have many other derived exceptions that get thrown depending on when there is a problem identified in your code. Most of these are, at least the ones that are defined here, are thrown by classes in the .NET framework, and we're going to learn how to catch these predefined exceptions, but we're also going to learn how to define our own exceptions. So most of the exceptions that we're dealing with will derive from these two classes, the system.exception class and the application exception class. System exception class is normally thrown by your .NET runtime. And so these are things like your Stack Overflow or your argument exception. If someone enters a number that's too large for a variable to handle, or if you enter a string when your code is expecting a number, then you will get these types of exceptions. The application exception class was developed as a place for programmers to derive their exceptions, but generally speaking, today we tend to derive directly from the exception base class. Some commonly used ones are the following. The Stack Overflow exception occurs when you try to put a number that's too large into a variable. The end of stream exception may be thrown when you try to read past the end of a file. The overflow exception happens when you try to cast a number that can't contain the full value in that variable. So knowing that the .NET framework will throw these exceptions, what we want to do as programmers is catch those exceptions so that rather than halting execution and providing the user with a cryptic message that would be the default message that the exception handling provides, we want to provide a good message that provides a solid user experience to the user and also provides the ability to continue on and keep working on the program. So when we write our code, C# is going to look through the call hierarchy until it finds code that handles the exception. And so if you think of your program as a series of function calls, where one function calls another function that calls another function, all those calls are stored in the call hierarchy and within C#. And basically what C# does is ask, does the function that I'm currently executing have code to handle the exception? If it doesn't, it goes up to the function that called that function and sees if it has it. It'll then go all the way back up through that call hierarchy, and if it never finds any code that handles the exception, that's when you get that unhandled exception message, which stops your program. So what we can do to catch an exception is use this syntax. We create a try block, a catch block, and optionally a finally block. And we put the code that might cause an exception in the try block. we put code that handles any exception. So if the code in this try block causes an exception, the catch block will catch the exception, and we could potentially display an error message. We might write code to log this error in a database or send an email. We can use this catch block to do anything we want whenever an exception occurs. And we place code that we want to execute no matter what in the finally block. And so what we usually use the finally block for is anything that requires cleanup. For example, closing a file or closing a connection to a database. Note that the catch block and the finally block are all optional. You can have a try block with just a finally, or you can have a try block with a catch, or you can have all three. So let's look at how to write a try, catch, finally block. So I'm going to start a new project. It'll be a C# console application, which I'm going to call exception demo. And in main, I'm going to create this structure with just a try and a catch initially. And so I'm going to put code that might cause an exception in the try block and code that will handle that exception in the catch block. So I'm going to get two numbers from the console. And if I get an exception, and since I'm doing division, obviously if I enter a 0, I would probably get some sort of an exception. I'm going to get a message. So I'm going to build it and run this program. And let's say I put in number 5 and 2. And I get integer division that yields a 2. That seems to work okay. Let's see what happens if I enter the word 1. Obviously this is a string, it should cause some sort of an error, and yes, I get an error. And you notice that it displayed my error message. So, although my program terminated here, at least I was able to catch the exception. Let's see what happens if I put a blank in. Again, I get my error message, and I don't get the ugly "you had an exception" message. It uses my custom message. So again, this provides a better handling of my errors. If I put 5 divided by 0, I do get an error. Of course, this is not a very specific error message. It would be nice if we could actually tell the user what they did wrong. So what we can do is we can change our catch to say catch exception, and we're going to just say exec. And what this will do is it will catch any generic system exception. And since since all exceptions inherit from this exception, basically that will mean that any type of exception should be caught. And what we can do then is we can say error, and if we look at the exception exec and hit a dot, we can see that there are several things we can get out of this exception class. We can get the source. We can get the message, which is a message which describes what was wrong. And we have several other things that we can also use as well, but for now we're just going to look at the message. So I'm going to display the message from the exception that we get, plus we're going to look at the type of this exception. So again, if I look at this exception, I can actually get the exception's type. And we're going to see that different things we enter will result in different error messages. The other thing I think I'll do is I'm going to wrap this in do another block. So what this will do is I have a do loop, which basically will ask the user if they want to do another. And we'll see that when we catch the exceptions, we can keep going around and trying again. So we'll try our test cases. I'll enter a number, 5 and 2, and that worked. Yes, I want to do another. I'll enter 1, and I get my error message. And we see that the error message is input string not in the correct format. And so this error display, the message that we got was input string was not in the correct format. That's what we got from this exception class. And the type we displayed here is a system format exception. We're going to do another one, and let's try blank. Again, we get a system format exception. And then I'm going to put in 5, enter 0. Notice that here, when I try to divide by 0, I get a divide by 0 exception, and it has a different message. So depending on the type of exception that we catch here, we might get different results. And we could actually do an if-then to check for this, but we're going to find there's a better way of catching different types of exceptions and creating custom messages. Because what you might want to do is, if it's a format exception, just tell the user that wasn't a valid number, please try again. And if it's a divide by 0, we can say you can't, if it's a divide by 0 exception, we can tell them, hey, you can't enter a 0. The next thing we want to demonstrate is this finally block. And for our finally block, we're just going to display a message that this section always executes. When we teach how to use a database or file operations, we'll talk more about this finally block. For now, we'll just do this message just to show that the finally block always executes, even when you have an exception. And so if I enter some good numbers, notice that we get the answer from this right line, and notice that the finally block executed. If I put something incorrect, I get the error message, but it still executes the finally block. That's why this finally block can be useful to do cleanup operations like closing a file or closing a database or releasing any resources which you don't want to tie up indefinitely. So the other thing we could do is, it'd be nice to catch different exceptions and provide custom messages for each of those exceptions. You can actually do that. And the way you do that is you have your try block, which has your normal execution code, and then you have multiple catch blocks, and you put the type of exception you want to handle in those individual catch blocks. You can add a catch block for the basic exception class if you want at the bottom to catch everything that isn't caught above. And so that's probably a good practice, is just put a generic exception here in case you didn't identify all the possible exceptions that could be caught above. And you might just put something generic in here, like tell the user that something went wrong and please contact their administrator. C# will go through each block in the order until it finds an appropriate exception. So first it checks to see if it gets an argument exception, then it checks to see if it gets a null reference exception in this case, and then finally everything else would be caught in this exception block, this generic exception. If you didn't have this generic exception, it would throw the exception up through the function call stack, possibly getting up to the top and displaying the unhandled exception message. So if you catch specific exceptions, realize that if it's not one of those, the exception may get thrown out of this function and be thrown up to a function higher up in the hierarchy. So we saw that we got a format exception and overflow exception. And so what we can do is we can add catch blocks specifically for those. And so here I'm going to catch a format exception and another catch for a overflow exception. And in the format exception, I'm going to just tell the user that they didn't enter a number. And the overflow exception, I'm going to tell them that their number is too large or too small. And we'll try this out. You have to close any running programs before you can build. So we'll try that again. There we go. So if I put num1 and 5, that works. Do another. Not a number. Notice that now it's caught the format exception. And we'll put a really large number. And it tells me that number's too large. And let's see if we can make something happen. Outside of those two. And we probably are catching all the possible exceptions. Let's see if we can maybe do a divide by 0. And we notice that we didn't catch the divide by 0 exception. So if we wanted to catch that, you could just add another catch block. And now we're catching the divide by 0 exception. So you can test your program, and if you get an exception, an unhandled exception, you can add another catch block to catch that. So you can also, if we wanted to write code that threw exceptions, we can actually make code that that actually throws exceptions. So typically, catch blocks are written in the class that's presenting information to the user because we don't want to display errors from, say, a class that we created that's being used by our main program. So in a console application, often we want to do all of our input and output from our user from main, or something that's very close to main. We try to separate our concerns so that we have one class that's doing user input and other classes that are essentially modeling data or providing functionality. So in this case, typically if you write a class, you will throw, if you find a problem when you're in your class, you won't display the error directly from the class. You will throw that exception up to whatever is using your class. And so library classes are typically where we write code to throw our exceptions. So system.exception, the class that is the base level exception class, has certain attributes. We already used the message, and we use the get type, which actually derives from the object-based class. But you also have some of these other properties that you can use. You have data, which used to supply extra information about the exception. You can actually write your exception class so it may have a help link that points to a web page that will give more information about how to deal with that exception. If you're providing a framework if you're building a framework, that's probably a very good idea. The inner exception, you can actually have exceptions that collect other exceptions that have been thrown up the hierarchy. So you can have an exception that belongs inside of another exception. The message we already saw. The source is the application or object that caused the exception. The stack trace actually provides you a list of all the methods that were in the call hierarchy, and then we have a target site, which is a object that describes a method that threw the exception. Stack trace and target site are supplied automatically by .NET. Source will always be filled in by .NET random time as the name of the assembly, which is typically your project name in which the exception was raised. Data, message, help link, and inner exception must be filled in by the code that threw the exception. So if you want those to be available to someone using your exception, you have to provide those. We'll mostly be using message when we build our own exceptions. So let's look at writing our own class that will throw an exception. And suppose we wanted a application that took care of Social Security numbers. So I'm going to write a class called Social Security Number that is going to represent a Social Security number. And we're going to use a string to store the Social Security number, and we're going to have it's going to have a property. And inside of this property, one of the things we are going to want to do is validate in the set that the value that was provided to us for this Social Security number is actually valid. So I'm going to use a regular expression to do this. I'll create a pattern. And if you know your regular expressions, you can write this from scratch, or you can find a number of standard regular expressions to represent this. And I'm going to use the regex class. It doesn't know what the regex class is because I haven't added using block for it. So I'm going to hit Control dot, and that gives me the regular expression class here. And regex has a method called isMatch, and basically you pass the value you want to check, which conveniently, because value is the keyword that gets passed in, we can just use value, and the pattern, which is this pattern up here we created. And so if the pattern matches, if what they provided me matches this pattern, then I'll set that value. Else, I'm going to, now the instinct might be at this point to do a console.writeLine. The problem is if I console.writeLine here, what ends up happening is, what if I'm doing a GUI application? If I'm doing a GUI application, then this won't display. So I really don't want to do IO from inside my class. What I want to do instead is I want to throw an exception from this class. And so anything setting this value into this property, if it doesn't match the pattern, they're going to get an exception. So let's save that. And in our program, so we've changed our try block. We asked the user for a social security number. And I'm going to get rid of these extra catch blocks, so we just catch the exception. And with this code, we ask them for a social security number. We get the user input. We create a social security number object called SSN and make it a brand new one, and we assign the user input into that property, the SSN property. When you assign it into this property, you'll call the set for that property, check the value that you entered against the regular expression pattern, and if it matches, it'll set it into value, otherwise we'll get an exception. So we're going to try this. And we enter a social security number, and I'm going to enter something that's definitely not a social security number. And we see that we get just a generic exception, and we get an error. Obviously, that's not very specific or very useful for the user. Let's try another one. And we see that it did accept just something that is in the format of a social. So it'd be nice if we could make that exception more specific. And we can do that by doing the following. One thing we could do is we could actually repurpose an existing exception. So maybe what we throw is a format exception. And one of the overrides with the exception class is if you look through here, you can add your own custom message, or you can make a message with an inner exception, which means that you would add an exception on the inside. But we're going to use the string message one and just say something like not a valid social security number. If I run this now, and I put something that's not a valid social security number, we see that we get the format exception, but we get a nice message at least. So when we display the message, that message that we put into our social security code is what was displayed. So that's one option that we can use. We can repurpose an exception and make a custom message. Another approach that we can do is we can actually create our own exception. And the way we do this is, as usual with C#, we write a class. And we're going to call this SSN format exception. And we're going to inherit, so that's what this colon means, from the exception class. And what inheritance means is that we're going to get all the properties, methods, and fields that this class has when we create this. So right off the bat, SSN format exception actually has some functionality. The one thing we don't get from a class we inherit from, though, is a constructor. So we need to make a constructor for this exception. And what our constructor will do is call the base class constructor, which we can do with the keyword base. And we're going to use that overload. You can see that base here is obviously referring to the exception constructor. And there's 4 overloads, one with the message, one with the inner exception, one with some other stuff. And we're going to use the exception that has just a string and put our error message in here. And what this will do is our SSN format exception constructor will call the base class constructor and provide a default message for it that says not a valid social security number. And because it inherits from the exception class, we can, rather than throwing a format exception, we can throw our brand new system format or social security number format exception. So we have our custom format exception that we created that will be used by the social security number class that we created in order to inform our main program that we have an error. And let's see what this looks like. Bad social security number. It says error, not a valid social security number. So we got the error message that we put in, and it's a good message. And we get our SSN format exception, which is a custom format exception, a custom exception that we created, which is nice because we can then catch that exception with a specific catch block. And so because we can catch now that specific exception, we know that if it was just a generic format exception, we wouldn't be able to know which type it was. But because now it's a specific SSN format exception that we're catching, we can make this message be very specific. And that tends to improve the user experience. So let's say they made a very simple mistake and omitted a number. They can look at this, oh, I didn't put it in the right format, try again, and then it works. So that's why we want to have the capability to create our own custom exceptions and have them have their own specific messages and throw them from the classes we create. So when you create a custom exception, you're typically throwing it from a class that you create. You typically wouldn't throw it from the GUI. You'd throw it from the class you created, and you would catch it in the class that's doing the user interface. So that concludes my demonstration. Thank you very much.